right, one last example here, this example 4, and this one's a little bit weird because if you look at what we started with, triangle ABC, or ACB as I outlined it, is not a right triangle. But if we draw that altitude down the center like we have, we can see that it makes right triangles. It makes two right triangles. The smaller ACD and the other ABD as well. Okay, so ABCD is isosceles. Remember, isosceles means two congruent sides, two congruent angles. So we know that AC is equal to AB, right? Those are my congruent sides. And I know that this angle C here is congruent to this angle B. Not that any of that's essentially really helpful right now, but just to know. So they tell us that AC is equal to 55. So we know that this is 55. We know that AD is equal to 49. So that's this. And they're asking us to find BC. Ooh, this one's going to be complicated. So finding BC would be this entire piece. That's what we're looking for. However, I can't find that all in one step because that CB or BC, whichever way you want to look at that is one side length of the not right triangle. So before I can find that entire CB, I have to first start by just finding CD. So let's make a note of that. Before we can find the entire CB, we must first find CD. We know that an isosceles triangle, the altitude bisects the base, making CD equal to DB. That's what we're going to use to find the entire CB later. So highlight and focus on the triangle that we're working with here, and that would be this right triangle. Okay, so we know that my hypotenuse is this 55. So that's going to be my C value. So I have A squared plus B squared equals C squared. We know that my C is that 55 because that's my hypotenuse across from my right angle. And again, it doesn't matter which one you use as which. I'll call this B because that's what we're looking for. Actually, let's call it A to not be confused. So we're going to leave A squared as what we're looking for, plus we know that that other side is 49 squared. Oh my. I just had breakfast. Excuse me. All right, so we're squaring 55 because who knows what that is. We're squaring 49 because also who knows what that is. So 2401, so A squared plus 2401 is equal to 3025. And again, here we're just solving for that A, for that missing variable. Minus the 2401 to both sides. So minus, I'm just going to do it backwards. So 624, but it's positive because I put it in the calculator backwards. A squared. Again, undoing that square is just the use of the square root. So shoop whoop, swoop whoop. A is equal to the square root of 624. 24.979. 24.979 ... You're almost always going to be getting decimals with these kind of problems. Okay, last but not least, find BC to the nearest integer. So if we rounded that to the nearest integer, when they say integer, let's make a point of that. That just means nearest whole number. That would round to CD being equal to 25. Which means if CD is 25, I know that BD is also 25 because we know that those are equal. Which means that the entire length of CB or BC would be equal to 50. So that tells us, I don't know, I'm trying to use a different color. BC is equal to 25 plus 25. BC is equal to 50. So that's about as hard as look at. You have 1, 2, 3, 4, 5 practice problems.